So, we're going to talk today about solving rational inequalities, which is going to be different than solving the equations that we have already looked at in a few ways. So, whenever we were solving equations, so I'm going to just write this over here to the side. Like if I had x minus 5 over 4 minus x equals 0. So if I was dealing with an equation here, at least Connor can't use his phone in class very easily. He's gonna have a pocket full of he's gonna have a pocket full of rubber bands by the end of the day, where they slide off. So if we have an equation like this, the denominator really doesn't matter that much because we could multiply through by that denominator 4 minus x and 4 minus x, and it would kind of go away. We'd just get x minus 5 equals 0, so x would equal 5. Okay, so with an equation, we can cancel the denominator. With inequalities, we cannot cancel the denominator. Okay, so whenever we have an inequality, the way that we're going to do these problems is the first thing we're going to do is we're going to make sure everything is moved to one side. Today, we're only going to see ones where everything's already on one side. Well, not tomorrow, like Thursday, whenever we, after our midterm, after we move on from this, we will have ones where we have to move it and solve. Today they'll already be on one side. We would need to get common denominators if they don't already have it, but today we're going to see ones that already look like this. So what we're going to do for this is I'm going to write this down. We'll move everything to one side. We will get common denominators. And combine. So these first two steps we're really not going to see much today. I don't think at all today. They'll be on the second part of these notes. Then the step that we're going to do next is we're going to set each factor equal to 0. Okay, so you want it in factored form. This is already factored because it's a very simple equation. So our factor from our numerator would just be this x minus 5, and we'll set it equal to 0, which will just give us x equals 5. And then our denominator will have 4 minus x equals 0. So 4 would equal x if we move that x over to the other side. Okay? Yes? So what I did is I just did like a plus x right here to move that x over, which is going to give you a positive. Or you could do it this way, 4 minus x equals 0. So you would move the 4 over, but you'd have that negative x would equal negative 4 if you do it that way. So you would still have to divide by that negative. So you should get a positive there. All right, so we get 4 and 5. We are going to put these numbers on a number line. And test points. Okay, so let me show you what that looks like. first of all, before we do that, I guess we should look right here. This is whatever expression I have here, x minus 5 over 4 minus x, it is supposed to be greater than 0, right? So what does that tell us about the number if it's greater than, greater than 0? Positive. It is positive. So we're looking for positive numbers. That is why we always want to move everything to one side, because we always want it to be greater than 0 or less than 0, so we know we're looking for positive or negative numbers. Okay, otherwise it would be impossible to really solve. So what we're going to do is we're going to take these numbers. When you get to calculus, we do something similar with this, that's derivatives and whatnot, and we would call these our critical numbers. Technically for these, they're not called critical numbers, but we could call them that if we wanted to. So we've got 4 and 5 will go here. And so at 4 and 5, you're going to have a 0 either in the numerator or denominator. And so these are going to be the points where you got a possibility of switching from positive to negative. Because if you were going from a positive number down to a negative number, you have to cross 0, right? Or if the denominator is 0, it could be there's a vertical asymptote there, and you're going to cross the x-axis there that way as well. So these are the points where we might switch from positive to negative. So what that tells me is that any number in this section right here should have the same sign. They should all be positive or all be negative. So what we're going to do is we're just going to pick one number in that section, and we're going to see if it gives us a positive or negative number. So we're looking at any number below 4. Blaine, what number do you want to try? 2. So if we try 2, we're plugging it into that expression we had to begin with. So we do 2 minus 5 over 4 minus 2. And that would give us negative 3 over 2. All we really care about here is whether or not that number is positive or negative. And this one is going to be negative right there. Now, it should have the same sign no matter what number we pick. So if I'd picked 0, I would have 0 minus 5 over 4 minus 0. I'd get negative 5 over 4. If I pick negative 7, it should still give me a negative. If I pick 3, it should still give me a negative. So anything in that section should be negative. Then we want to look at this section right here. So for that section, you are going to pick something between 4 and 5. Probably 4.5 is your easiest bet. So you got 4.5 minus 5 over 4 minus 4.5. And so you'll get negative 0.5 in the top. And you'll also get negative 0.5 in the bottom. And if you have negative over negative, what's that going to give you? Positive. So you get a positive right there in the middle. And that should be the case for anything between 4 and 5. So if we did 4.1 or 4.9 or 4.2, we should get the same there. And then the last section that we're going to look at is anything bigger than 5. Okay? So Summer, pick me a number bigger than 5 that you want to try. All right, so if we do 10, we got 10 minus 5 over 4 minus 10. 10 minus 5 is going to be 5. 4 minus 10 is going to give me negative 6. And so is that going to be positive or negative? Negative here. So we would have negative in that section. So our answers, remember we said up here at the beginning, our answers are anything that's positive, right? So the answers are this section right here where the answer would be positive. So we could either say 4 less than x less than 5, or we could write it with interval notation for 5. Notice I did not use an or equal to sign here because I want numbers that are greater than 0. So at 4 or at 5, they would equal 0 or undefined actually for the 4. But because we just have a less than sign here, we're not going to use the or equal to signs anyway on our answer. So this would be our answer now. questions? Okay, let's look at this next one that we've got here. And I'm going to show you a strategy that I use that I think makes this a little bit faster to do. If you don't like it, you can do it like we did the first one. It's fine. The first thing we want to do, thankfully, everything's already moved to one side. Everything already has a common denominator, and it's already even factored for us, right? Sometimes we might have to factor these, but this one is factored for us. So we're just going to take each factor and set it equal to 0. So x minus 3 equals 0. That'll give us x equals positive 3. X plus 2 equals 0. So that'll give us x equals negative 2. And then x minus 4 will equal 0. That one's squared. That just means it's going to be there twice, but you don't have to do it twice. So x equals 4. So I'm going to leave myself a little bit of room here and put my number line down here, and I'll show you why here in a second. And I'm going to put these numbers, make sure you put them in order on your number line. So you need negative 2 over here, then 3, then 4. It doesn't have to be to scale or anything. Okay, so at this point, you have the option of just plugging numbers in to this equation. But I'm going to use this little chart to help us do that in a sort of like a little bit quicker way. So I'm going to list my factors over here on this left-hand side. So I've got x minus 3. I've got x plus 2. I've got x minus 4 squared. And I'm going to put down here, I'm going to put a part for my answer. And I'm going to make myself a little chart here. So I'm going to draw the lines here, draw lines across like this. Okay, so I like to do this because it makes it a little bit quicker to plug in numbers here. So first of all, I'm going to start with this line right here. If I've got x minus 4 squared, what's the sign going to be when I plug any number into that? It's going to be positive. And why is it going to be positive? Because you're squaring it. And so if you square anything, it's going to become positive. So I could know this whole entire line right here is just going to give me a positive number. So that tells me the denominator is always positive here. So now I'm going to think about the x minus 3. The x minus 3, I'm just going to start picking numbers and plugging them in. So if I'm picking a number less than negative 2, so we're looking at this section right here, negative 2, I might think of negative 3, right? That falls in this section, or negative 4, negative 5, it doesn't matter. I usually try to pick something small. So if I do negative 3 minus 3, that's going to give me negative 6, so it gives me a negative in that section. I could pick me a number between negative 2 and 3. I see that 0 is there. That will make this easy, so I like to use 0. So 0 minus 3, what does that give us? Negative. Okay, between 3 and 4, probably like 3.5 is the number I'm thinking of there. So if I plug in 3.5, 3.5 minus 3, positive. And then anything bigger than that's also going to be positive, right? So if I plug in, for example, right here, if I plug in 5, 5 minus 3 would also be positive. You will notice that here I've got x minus 3, and it changes signs at 3. It's not always negative to positive, although if it's written like this, it's usually negative positive. If it was like 3 minus x, it would be positive to negative. So I get that line. And then x plus 2, I'm going to do that same thing. So if I've got negative 3 plus 2, that would give me a negative. If I got 0 plus 2, that'd give me a positive. And then anything bigger than that is also going to give me a positive. So like 3.5 plus 2 would give me positive and positive. Again, you can see the signs switch right there. The critical point that goes with x plus 2 would be negative 2. And our sign switches right there. Okay, so this is all just like work to figure it out. I've kind of went a little slow explaining what you're doing here. But I like this because I think it's a little bit faster, because the value really doesn't matter. It's only the signs that matter. So let's think about what we've got here. For this, we would have a negative times a negative divided by a positive, right? Because we have x minus 3 times x plus 2 over x minus 4 squared. So if I've got negative times negative over a positive, the negative times negative will give me a positive, and I'm dividing it by a positive, which is going to give me a positive answer there. If I think about this here, I would have negative times positive over positive. What's that going to give me? A negative. And for these last two, I've got positive, positive, positive. Everything's positive, right? So I'm going to get positives there. So this last line right here, this line that I call answer, that's what we're looking at to answer the question, right? This is just work leading up to it. Another hint right here that I'm going to tell you is when you're looking at this lines right here, these 3 lines right here, if you have an even number of negatives, the answer is positive. And if you have an odd number of negatives, the answer is negative. Because you're multiplying and dividing everything there if you've got it factored correctly. So if you're multiplying numbers together, if you have an odd number of negatives, you're going to get a negative answer. If you have an even number, you'll get a positive answer. So really, rather than even thinking of it like this, I can just see, oh, I've got 2 negatives there. That's an even number, so this is positive. I only have 1 negative here. That's an odd number, so this is negative. Obviously, if you only have positives, you're going to get a positive answer for those. All right, now let's talk about what the answer actually is for this. I've got, if I look back at my original problem, I've got less than or equal to 0. So am I looking for positives or negatives as my answer? Negatives. And so this is a little bit tricky here because this one is less than or equal to. So when you have the or equal to, you just got to think a little bit harder about your answer. So I'm looking for negatives. Negatives are right here. That's the only section that gives me negatives. And so I'm going to say negative 2 less than or equal to x less than or equal to 3. But I do need to stop and think whether or not I can actually have negative 2 or 3 as answers. Okay? Because if they give me zeros in the denominator, I don't want to include those. Is it okay to have -2 as an answer? It is fine because it's in the numerator here. The factor that goes with that is in the numerator. 3, how about it? Also okay because it comes from the numerator. So if I had 4, I would want to exclude that point, and I would go back and like erase the or equal to part there, and just have less than. Okay. All right. So this would be our answer here for this. You could also write it in interval notation. It would look like this. Now, just in case you don't like the chart, you don't have to use the chart. You could, for each one of these, ignore the chart. You will still need the number line. You'll need this right here. You could just for each section, instead of doing the chart, you could just do, like if I plug in -3, I could do -3 minus 3 times -3 plus 2 over -3 minus 4 squared. And then just see here, you would get like -6 times -1 over -7 squared, which would give you +6 over 49. So you can see there that you would get a positive in that section. All this is doing it piece by piece. It can be a little bit faster whenever you have lots of sections that you need to look at. All right, so let's try another one. So this one, everything is moved to one side. We have a common denominator because we don't have any plus or minus signs in between fractions, but it's not factored. So we do need to factor it first. So, Reese, how do we factor that numerator? Very good. And Grace, how do we factor that denominator? Perfect. All right, so you don't want to cancel things here because it can affect your answer. So even though the x minus 2's will cancel each other out here, we don't want to cancel anything. We don't cancel denominators away. We want to include everything here. So we would take each one of our factors. We have x plus 2 would equal 0, which would give us x equals -2. We would have x minus 2 equals 0, which would give us x equals +2. We would have x plus 5 equals 0, so that would give us x equals -5. And then the x minus 2, we could do it again, but it's just going to give us 2 there. As far as the numbers, you don't have to do it twice, but when you make the chart, you want to write each one of these down. So I'm going to put these in order. So I've got -5, -2, and +2. And I'm just going to list each of my factors over here on the side. So I've got x plus 2, x minus 2, x plus 5, x minus 2 again, and then I would put the answer at the end. So I think the chart's particularly helpful whenever you're dealing with one that has lots of factors like this. So, again, you're just picking numbers that fall in between the sections here. So here on this part, I'd be thinking of something less than -5, so -6. And if I plug in -6 plus 2, that's going to give me a negative in that section. And then if I plug in something between -5 and -2, like -4. -4 plus 2 would give me still a negative there. if I plug in something in this section from -2 to 2, like 0, 0 plus 2 would give me a positive, and then anything bigger than 2 would also give me a positive. X minus 2, same thing. -6 minus 2, that'd be negative. Right here, -4 minus 2, still negative. 0 minus 2, negative. And then finally, anything bigger than 2 would give us a positive. I could go ahead here, because this is the same factor, I could just copy that down here for this line, because it's the same factor. And then for the last one, you got that x plus 5. So if I plug in like a -6, that would give me a negative. But then if I plug in a -4 here, -4 plus 5 would give me a positive. And so anything bigger than that, 0, 3, those would all give me positives as well. Any questions on looking at that? Okay, so then we're just going to look at the columns here, and if we have an even number of negatives, our answer is positive. So I've got 1, 2, 3, 4 here. That's going to give me a positive. Here I've got 1, 2, 3. That's going to be negative because it's odd. Here I've got 2. That'll give me a positive. And of course the last one, because those are all positive, is going to give me a positive. Okay, my answers for this, are they positive or negative? Positive. Because from the beginning it was supposed to be greater than 0. So for my answer here, I would say x is less than -5. And then -2 is less than x less than 2. And then x is greater than 2. Here, so it's all 3 of these sections. You don't want to include that 2, even though it looks like it's positive there, because at 2 it's going to either equal 0 or undefined. I think it's undefined, actually. So it can't actually equal 2. So you want to list those separately. You can also use interval notation. I like interval notation better on this one. It'd be -infinity up to -5, -2 to 2, and then 2 to infinity. So either one of those, this or this, would be fine. So we had a couple more examples to get to, but it's really just more practice of the same thing. So I'm